This is the physical science lesson video for section 15.1. And as always, if you want my videos all in one place, just subscribe to my channel. So chapter 15 is on energy. So section 15.1, we're just going to kind of introduce energy. So energy is the ability to do work or supply heat. When work is done on an object, the energy is transferred to that object. So think about pool balls. When one is moving and hits another one, that energy is transferred and propels the other one. Both work and energy are measured in joules, which if you learned in chapter 14, we learned work is joules. Energy is also joules. So that's a unit we're familiar with. So many forms of energy can be classified into two general types, kinetic energy and potential energy. So clearly we need to take some time to discuss those, and we'll talk about how to calculate both of them. Kinetic energy is the energy of motion, and the formula for kinetic energy is Ke equals 1/2 mv squared. Where Ke is kinetic energy, it's going to be in joules. Your mass is m, it's going to be in kilograms. And your v is velocity, it's going to be in meters per second. Now the thing you need to realize is that only the v is squared. So when you're putting it in your calculator, don't square the whole thing. It's 1/2 times m times v squared. Okay, and so it's energy of motion. So as something is moving, its kinetic energy is changing. So notice that doubling the mass would double the kinetic energy. So here I've just plugged some random numbers into the formula. So if we have 50 kilograms and 10 meters per second, but then we double the mass, what I want you to notice is kinetic energy also doubles. However, because velocity is squared, if you double the speed or velocity, it actually quadruples the energy. So if you compare these two, see we have 50 kilograms for both, but we've doubled the velocity, the kinetic energy has quadrupled.
Ms. Goins, if you can please come to the counseling office. Ms. Goins, if you will please come to the counseling office. Thank you.
Yeah, sorry, hopefully that won't happen too much. I'm doing this one after school today because I didn't have a planning period. So anyway, so notice that your kinetic energy quadruples, because if you plug in 2 squared, that's really 4 times the amount. And then just don't forget from chapter 14, 1 joule is a kilogram times meters squared per second squared. Because see, if you look, you'll have kilograms and then you'll have meters squared, second squared, and that's where we get joules from. So let's look at some examples together. So we'll do the first one together and then maybe pause it and you try the second two. So it says a 0.1 kilogram bird, so there is our mass, is flying at a constant speed of 8 meters per second. So there's my velocity. What is the bird's kinetic energy? So I'm looking for my kinetic energy. So I don't need to rearrange my formula at all. So Ke is 1/2 mv squared. And so I just plug in. So 1/2, my mass is 0.1 kilograms. And my velocity is 8 meters per second. And again, I'm only squaring the velocity. So if you'll put it in parentheses when you square it, that will make you only square that one number. Alright, so once I solved, I ended up getting 3.2, and my unit for energy is joules.
Shaquan White, please come to the front office. Shaquan White, please come to the front office.
Well, that's probably going to happen a lot. Alright, so maybe pause it, you try the next one, and we'll look at it together. So it says a 70 kilogram man, so there's my mass, is walking at a speed of 2 meters per second. So there's my velocity. What is his kinetic energy? So again, I don't need to rearrange the formula because we're solving for kinetic energy. So kinetic energy is 1/2 mv squared. So I plug in my 1/2. My mass is 70 kilograms. And my velocity is 2 meters per second. And I'm going to square that. And so once I multiply and square and everything, I got 140, and my unit for energy is joules. And another calculator hint besides the parentheses, so you only square the velocity, is if you're having trouble with the 1/2, just type in 0.5. 1/2 and 0.5 are the same thing. So again, try the bottom one first. You will have to rearrange, so try that one on your own, see if you can do it, and then let's look at it together. So it says a 50 kilogram cheetah, so there's my mass, has a kinetic energy of 18,000 joules. So here is my kinetic energy. How fast is the cheetah running? So what would how fast be? That's the speed or the velocity. So here I'm actually looking for velocity. So we're going to have to rearrange this formula. This one's a little tricky, but you can do it. Alright, so we have Ke equals 1/2 mv squared. We're solving for v. So remember, we got to get everything else on the other side. So we just do the opposite of what's happening. So right now, 1/2 means we're dividing by the 2. So what's the opposite of dividing? Multiply. So I'm going to multiply both sides by 2. So see, the 2's cancel. So I'm going to get rid of the half, just so it doesn't throw you off. Alright, well now I still have mv squared, so I got to get rid of that m. Well, right now we're multiplying m and v, so what's the opposite of multiplying? Dividing. So I divide both sides by m. So see, then those cancel. Alright, so I'm just going to get rid of them right here. But the problem is, I'm still solving for v squared. So what's the opposite of squaring something? Square rooting it. So I'm going to square root this side, which means I need to square root this side. Whenever you square root something that's squared, it's just that thing. So v squared with a square root is just v. So v is the square root of 2 times your kinetic energy over mass. And so once we have that, we can just plug in. You've got to be able to rearrange formula. I know I keep saying that, but it's because it's true. So I have 18,000 joules divided by my mass, which is 50 kilograms. And so once I solve, and don't forget to square root, that's the problem. Is some of y'all, you plug in the numbers, but then you forget to square root your answer. Once you square root, you should get 26.8. And then let's look at units real quick. There's 2 ways you can get units. One, we're solving for velocity. So if you just remember units are meters per second, that's fine. However, let's say you don't. We have a joule on top. Well, remember, a joule is a kilogram times meters squared per second squared. And we're going over a kilogram, and then we're square rooting the whole thing. Well, kilograms cancel, and if you square root meters squared, that's meters. If you square root seconds squared, that's seconds. However, for most of you, it'll be easier just to remember velocity is meters per second. That's probably the best way. Alright, so hopefully you got at least one of those right. That last one was kind of tricky. So that's how you calculate kinetic energy. So now let's talk potential energy. So potential energy is the energy that is stored as a result of position or shape. So example, lifting a book increases its stored energy, but letting the book go turns the energy into kinetic energy. 2 forms of potential energy are gravitational potential energy and elastic potential energy. So potential energy, when we see the formula, you'll see it's based off of height. So if I take something from the ground and lift it to a higher height, I'm increasing potential energy. But as long as I'm just holding it here, it's not moving, it doesn't have a speed, so it has 0 kinetic energy. However, if I let the book go, its height is going to decrease, so its potential energy decreases, but its speed is going to increase, so its kinetic energy increases. So they kind of go vice versa. Like think about a roller coaster. Every time you go higher, you start slowing down. So you have high potential energy, low kinetic. But then as you start going downhill, you speed up. But because you're going lower, or your height is decreasing, you have less potential energy, but now you're going faster, so you have more kinetic energy. So they kind of go like this. They go back and forth. So potential energy that depends on an object's height is called gravitational potential energy. So that's the one I was just talking about. This type of potential energy increases when an object is raised to a higher level. So if you have somebody standing on the sidewalk versus somebody standing on the top of the skyscraper, the person on the top of the skyscraper would have more potential energy because they're at a higher height. So the formula for potential energy is PE equals mgh. So PE is, of course, potential energy. It's going to be in joules. M, again, is mass. It's in kilograms. If you remember, G is gravity. It's 9.8 meters per second squared, and height has to be in meters, and that is h. All right, and then all of those units together will give me joules. So noticing that if you double the mass or the height, it doubles your gravitational potential energy. So since there's nothing squared here, everything just doubles. So see, if I double my mass only, my potential energy doubles. If I double my height only, my potential energy doubles. So it's not a quadrupling like in the kinetic energy formula. So the potential energy of an object that is stretched or compressed is known as elastic potential energy. So think about if you're shooting an arrow. Okay, as you stretch and then that string compresses, that is elastic potential energy. The major forms of energy are mechanical energy, thermal energy, chemical energy, electrical energy, electromagnetic energy, and nuclear energy. Each form of energy can be converted into other forms. So there is a law of conservation of energy. So total energy cannot be created nor destroyed, But like I was talking about with the roller coaster, potential energy and kinetic energy, they can turn into each other. So the different forms of energy can transform into one another, but the total energy must remain constant. So the energy associated with the motion and position of everyday objects is called your mechanical energy. Mechanical energy is the sum of an object's kinetic and potential energy. The total potential and kinetic energy of all microscopic particles in an object make up its thermal energy, because thermal energy is based on the speed of the particles in a substance. When an object's atoms move faster, its thermal energy increases and the object becomes warmer. So the faster particles move, the hotter the temperature. And if you cool something down, the particles move slower. Chemical energy is the energy stored in chemical bonds. When bonds are broken, the released energy can do work. So that's how chemical reactions can do work, is through that energy in the bonds. Electrical energy is the energy associated with electric charges. Electromagnetic energy is the form of energy that travels through space in the form of waves. So like, for example, X-rays. And the energy stored in the atomic nuclei is known as nuclear energy. And through various chapters throughout the rest of the year, we'll dive more into each of these types of energy. So, describe the relationship between work and energy. Well, remember, energy and work are both in joules. Oh, I don't know why I'm about to write that. You can say energy and work are both in joules. You can say energy is the ability to do work. Either one of those would be fine. So energy and work are both in joules, or energy is the ability to do work. Both of those would be fine. So how is the kinetic energy of an object determined? Well, it would just be its formula. So Ke equals 1/2 mass times velocity squared. Sorry, Ke equals 1/2 mv squared. Or if you wanted to put it in word form, you could say as long as you know mass and velocity, you can determine kinetic energy. All right, number 3, what factors determine the gravitational potential energy of an object? Well, potential energy is m times g times h. So mass, gravity, and height would be what affect the potential energy of an object. All right, mass, gravity, and height. When you heat a pot of water over a flame, what form of energy is added to the water? Well, if we're talking about heat, that would be thermal energy. Because remember, you're speeding up the particles, so there's a higher temperature associated with that. What kind of energy is represented by an archer stretching a bowstring? Well, that would be elastic potential energy. So remember, stretching and compressing is elastic potential energy. Can an object have both kinetic energy and potential energy at the same time? Well, sure it can. Think about a skydiver. When it jumps out of the plane, it has a height, so it has potential energy. It's moving a certain speed, so it also has kinetic energy. It's just what's happening is, when he's at the very highest, say he's not moving, he has only potential and zero kinetic. Once he jumps, his height is decreasing, so potential energy decreases, but his speed is increasing, so kinetic increases. Okay, so you can have both as long as you have a certain height and you also have a specific speed that you have. All right, so last one, it says a 60-kilogram person, so there is a mass, walks from the ground to the roof of a 74.8 meter tall building. So there's a height. How much gravitational potential energy does she have? So we're looking for our PE. So we don't have to rearrange the formula this time, so that's nice. So PE is mgh. So my mass is 60 kilograms. My gravity is 9.8 meters per second squared, and that's just a constant. And my height is 74.8 meters. And so once I multiply these three numbers, I get 43,982.4. And then my unit for energy, of course, is joules, which I would get because it's kilograms times meters squared per second squared. All right, so hopefully you understand about the difference in kinetic and potential energy and how to calculate both.